Hello, this is Mr. Win, and this video is about special right triangles. So the previous video showed how to use the Pythagorean Theorem when given a right triangle with two known sides. This video is related to that, but involves two special cases that you should memorize. Here you'll only get one angle on one side, but you should be able to figure out the other two sides using patterns. So the first one is, think about a square. A square you should know has all sides are equal to each other and all angles are equal to 90 degrees. So there's a little picture. Let's say all the sides are equal to 4, so I put 4 for every side, and we're going to draw a diagonal. Once I draw the diagonal, you should be able to see a right triangle with legs of 4 and 4 and a missing hypotenuse. A diagonal does bisect the angles of a square, so the angles are both 45 degrees. So looking at this picture, does that make sense? And the answer to that should be yes. If there are two equal sides, 4 and 4, there should be two equal angles, and vice versa. This is an isosceles right triangle. So the question is, can we solve for the missing side? Answer is yes. We just use Pythagorean Theorem from the previous video. So make sure you label A, B, and C. C is crossing the 90-degree angle. There's C. Let's call this A. Let's call this B. So A squared plus B squared equals C squared. That is 4 squared plus another 4 squared equals X squared. That is 16 plus 16 equals X squared. That is 32 equals X squared. I'm going to square root both sides. Unfortunately, 32 is not a perfect square, so I have to break it down on the side. I'll go over here on the right side. Square root 32. That is, let's do 2 and 16. 16, let's do 4 and 4. 4 is 2 and 2. This other 4 is 2 and 2. I find some pairs. There are a pair of 2s, another pair of 2s, and this last 2 is by itself. So outside will be 2 2s, and inside will be a single 2. That's really just 4 root 2. Again, the outside numbers multiply together. So we just found that 4 square root 2 equals x. The hypotenuse here is going to be 4 square root 2. I don't know, what if we got this picture below? Can we find all the sides? It said one side's 5, the other side's x, the other side's y. We just see a 90-degree angle, and we see a 45-degree angle. So you have to think of triangle sum. Remember, triangle inside angles, all three add to 180. So one's 90 and another one's 45, then this other one's also 45. Alright, now we have two equal angles, we have two equal sides. If 45 goes with 5, then this other 45 must also go with 5. So we know, first off, x equals 5. Alright, once you know two sides, you can do the Pythagorean Theorem. So let's label A, B, and C. Again, this is C because it's across the 90. I'll call this A, I'll call this B. So if in the Pythagorean Theorem, A squared plus B squared equals C squared. That's 25 plus 25 equals Y squared. That's 50 equals Y squared. I'm going to square root 50. That's not a perfect square, so I have to break it down on the side. Square root of 50. Let's use a 5 and 10. And then 10 is 5 and 2. Those are all primes. There are a pair of 5s. And the 2 is by itself, and that's all the numbers. So a 5 goes out, the 2 stays in. So we found y. Y is equal to 5 square root 2. And then we knew x was equal to 5. All right, so the two legs are 5 and 5, and the hypotenuse is 5 root 2. All right, so on the last two problems, two triangles we had angles 45 degrees, and 90 degrees. And the three side lengths in order were 4, 4, 4 square root 2, and 5, 5, 5 square root 2. And that is actually a pattern. That's not a coincidence. We call these 45, 45, 90 special right triangles. If you know the measure of the side across the 45-degree angle, the other side across the 45 angle will match it exactly because it's the same. Again, isosceles triangle. And then the side across the 90 degrees will always be the same thing, but you have to multiply by square root of 2. All right, so here's a little chart you should have. If you have the angles 45, 45, 90, the formula will be x, x, x root 2. For example, if the side across, let me do it like this. If the side across from the 45 is, say, 21, the other side will be 21, and then this one will be 21 square root 2. That's how you use the formula. If you know the small one, you just fill in x. All right. So to use the formula, more specifically, always try to find the measure of the side across from the smallest angle. If you know the x value, to go forward, you multiply But if you don't know it, you have to go backwards by dividing. So here's two little problems. Here on this left side, we have a 45-degree angle across the 10. Remember, if this is 45 and that's 90, then this other angle right here is also 45. So across this 45 will be some number. So let me do like this. I'm going to draw the chart. So I like doing this. We have a 45, 45, 90. The formula is x root 2. Across the first 45 was the number 10. If that's 10, the next thing has to be 10. The next thing has to be 10 square root 2. So I know this number is going to be 10, and this hypotenuse is going to be 10 square root 2. All right, over here, again, we have a 45, 45, 90 triangle. Let's fill in the formula. I like to make this little chart. So we have 45, 45, 90. Well, what does that 3 root 2 go with? It goes, 13 root 2, I mean. It goes with our 90-degree angle across the 90. So we put it right here, 13 root 2. We don't know x, but to go backwards, you divide by the thing on top of it. So we're going to do 13 root 2 divided by root 2. Well, those root 2's just cancel out. So you just get 13. So that means this is 13 and this is 13. So across from 45 is 13, across from the other 45 is also 13. That should make sense because it'll be 13, 13, 13 square root 2. All right, be careful. A radical can appear and disappear in any of the sides. So here's another example. Again, 45, 45, 90. I'll make that little chart. I always like putting the formula is x times square root 2. So our 3 root 2 goes right across from a 45. So I'll put it right here, 3 root 2. So that's across the 45. The other 45 must be the same thing, 3 root 2. And to get the 90, you can do the x thing times another root 2. So this can look weird, but it'll be 3 root 2 times another root 2. Well, you know when you multiply 2 root 2's, you just get 2, which will give us 6. Because remember, square root 2 times square root 2 is square root of 4. Square root of 4 is just 2. 3 times 2 is 6. So I know that this other side is going to be 3 root 2, and this is going to be 6. So I found all three sides. Over here, again, 45, 45, 90. We'll make the pattern. 45, 45, 90. X square root 2. Across the 90 is 11 root 6. I'll put it right here, 11 square root 6. All right, we don't know x, so to go backwards by division. So we can do 11 square root 6 divided by square root of 2. So remember, you learn how to divide these things, but to rationalize this, times it by root 2 over root 2. That gives me on top 11 root 12 over 2. But square root of 12 does change. Remember, you do the tree branch. That would be 11 times square root of 12 turns into 2 square root 3 over 2. And you could cross out now, but I'll do 2 steps for you. 11 times 2 is 22, and root 3 on top over 2. Remember, you have to reduce. 22 over 2 is just 11. So I will end up with 11 root 3. All right, so I know that this x will be 11 root 3, and this other one will also be 11 root 3. That should make sense. 11 root 3 times root 2 means 11 root 6. All right, so these are just 11 root 3's. All right, that's the first special right triangle. Here's the next one. We're going to think about an equilateral triangle. Equilateral triangles have all sides equal to each other and all angles equal to 60 degrees. So there's a little picture with the marks. Let's make all the sides equal 8 and then draw an angle bisector for the top. You should be able to see a right triangle with a leg of 4 and a missing leg and then a hypotenuse of 8. And if we cut the angle top, 60, this turns to 30. So there's 30. Here's a 6 from 4. If that's 90, that means this has to be 90. So again, it's a right triangle. Notice that the hypotenuse is double the leg from the 30. Just so you know, that's the big thing. So across from 30 is 4. Across from 90 is 8. You double that. Anyways, we can solve for the missing side using Pythagorean Theorem. So again, I'll just call these A, B, C. C is the 8. I call this A, I call this B. Pythagorean Theorem. A squared plus B squared equals C squared. 16 plus x squared equals 64. Subtract 16, I get 48. Square root both sides. 48 is not a perfect square, so I have to do the tree branch method. I can do 16 times 3. I can do 4 times 4. I'll teach you a trick. But if you don't break down a number and you find a pair, you can actually use that. So I'd say, oh, here's a pair of 4s. All right, and then nothing can come down from those. So 4 goes out, a 3 stays in. I get 4 root 3. So I get x equals 4 root 3. So that's how tall this triangle is. That's the missing leg across from the 60-degree angle. Again, let's try this. Let's label A, B, C. That's C, that's A, that's B. A squared plus B squared equals C squared. That is 36, 144. Subtract 36, I get 108. Square root both sides. 108, it's a kind of big number, but it is even, so I can say that is 2 times 54. 54 I know is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. I circle my pairs. I have a pair of 2s, a pair of 3s, and leftover 3. So 2 goes out, a 3 goes out, a 3 stays inside. That is 6 on the outside, 3 on the inside. All right, so we know that x equals 6 square root 3. That's the height. All right, so notice the two triangles we did had angles 30, 60, 90, 30 degrees, 16 degrees, 90 degrees, and the three sides in order were 4, 4 root 3, 8, and then 6, 6 root 3, 12. Again, that's not a coincidence, that's actually a pattern. We call these 30, 60, 90 special right triangles. And if you know the measure of the side across the 30-degree angle, the side across the 60-degree angle will be the same thing, but you multiply root 3. And the side across the 90 degrees will be the same thing, but doubled, so multiply by 2. Everything's based on the 30-degree angle, the smallest side. So there's our formula, like before. Try to find the measure of the side across the smallest angle. If you know it, you go forward by multiplication. If you don't know it, you go backwards by division. So for the first triangle, we have a 30, 60, 90. I'm going to roll the chart, 30, 60, 90. I'll put the formula in here. That's x times square root 3. That's 2 times x. The 7 is across the 30, so that's our x. So to go from 30 to 60, it's going to be x times the square root 3. Then to go from 30 to 90, I just do 2 times x. 2 times 7 is 14. So we found that this is going to be 14, and this is going to be 7 root 3. Over here, I'm going to do the pattern. 30, 60, 90, because it's a 60-degree angle. This is x root 3, 2x. All right, we know across the 60 is 8 square root 3. We don't know the 30, we have to go backwards. Go backwards, you divide. So we're going to do 8 root 3 divided by root 3. Well, these root 3's cancel out. So it's just 8. If you know the smallest one's 8, you double that to get 16 to get the largest. So that means this is 8 and this is 16. And again, don't use a picture. It's not drawn to scale. Just use the angles, the numbers. Right over here, this is a 30, 60, 90. This is 30 degrees. The formula x root 3, 2x. The 18 goes across the 90. Again, I need to know the 30-degree angles. I have to go backwards. I'm going to do 18 divided by 2. Well, that's just 9. So that means the 30-degree number is 9, and go forwards. 9 times root 3 will give me this. So this is going to be 9. This is going to be 9 square root 3. All right, last slide. Like before, be careful. A radical can appear and disappear in any of these. So I'm going to do the same thing. 30, 60, 90. X root 3, 2x. This 20 root 3 is across the 30. So this is 20 root 3. To go forward, you multiply. It's going to be 20 root 3 times another root 3. My root 3 times root 3 is just 3. So 20 times 3, that's 60. Then if you want to double the smallest, 20 root 3 times 2 is going to be 40 root 3. So we found the three sides here. This is going to be 40 root 3, and this is going to be 60. And if you type in calculator, 40 root 3 is a bigger number than 60. That's true because hypotenuse is the largest. And one more. All right, there's my chart. 10 root 5 is across from the 90-degree angle. To go backwards, I have to divide. So I'm going to do 10 root 5 divided by 2. 10 divided by 2 is just 5. This is 5 root 5. So the smallest is going to be 5 root 5. Then I'm going to do 5 root 5 times root 3. Well, that's just going to be 5 square root 15. That's it.